Dang nabbit, I can never find a parking space after lunch.
Cartoon Network keeps adding stars without adding parking space.
There's a space.
Okay, this is the final for Capstone Project for the parking garage. This is William Schwab, and we're going to take a quick walk around for what we've got for the project. Right here we have the controller assembly, we have the relay, we have 5-volt power supply, 24-volt power supply. This is the network switch that we don't use, and up here is a Micrologix 1100. And if we look at the screen, we can see the inputs on top, there's 10, and the outputs on the bottom. And these reflect whether there's 24 volts or not. And I can toggle some of the inputs, and you can see them go clear and go black. That means that the switch is being toggled. Up here is the control PC, and if we look at this green thing says we're in the run mode, but then there's also this icon right above my finger. If you can see it, it's rotating, and that means we're in the run mode. Over here is the parking garage, and what we have is buttons for each level, and then we have our actuator assembly and the motors for it. This is the actuator that actually pushes a car into the space, and on top is our rotating carousel where we can rotate to spots. And this is the motor for it, and here's a limit switch that tells us when we're in the proper position. And down here is our car sensor that tells us whether there's a car in the adjacent spot. And we'll have to have more detail on that one because the sensor has been a little problematic for us. Okay, and this is just to show our little car sensor. And when it has a red LED that it sends out, and then it has a reflector path that it comes back. So when anything comes in front of it, and you can see a green operational LED, but when anything comes in front of it, you can see that the orange LED comes on. And that's what we're using to test whether there's a car in the spot adjacent to our location, so we know whether to bypass it. Now, if you can see, we've got not very good mounting thing. These are just washers and nuts and whatnot, and they're tie wrapped, and it's not very good, and I'm not sure how reliable this situation is, but we'll see how it works. The way that the system works is the sensor senses whether there's a car in the next position. The first thing we do is go up to the level that we want to park at, and this one we'll try to park it on the second level. Now, because the sensor is looking at the adjacent spot, it knows whether that spot is empty or not. It doesn't know whether this spot is empty or not, so it has to rotate one spot and then determine whether it needs to park it or not. So here we're going to go up one spot, or up to the second level, rotate one spot, and then, because there's nothing there, we'll park it. And let's see what happens. We go and we rotate one spot. Now our actuator is a little difficult to work with because it does too much actuating. But now we'll take a look where if we have a car in the spot, we'll do the same thing, and now it has to bypass that spot. So again, we go up to the second level, rotate. Now there's something there, so we bypass it, and then we go back and we pick the spot that is open. And then the lift mechanism always returns to the home position. So that's the basic premise for this design. Okay, and here's a further demonstration of our parking garage. And what we have is, instead of having a space occupied, now we've got 2 spaces occupied, and then an open space. And then we've got over here 3 spaces occupied. So if it works correctly, we'll hit the 3rd floor, it'll come up to the level, it'll skip 1, skip 2, and then park it in the 3rd spot. So let's give it a go. So we're moving up to position, moves past 1, past 2, and it parks it in the 3rd spot. Now we go back to the home position, which is the 1st floor, and we'll go up again, and now we've got to miss 3 spots and park it. So we go past 1, past 2, past 3, and then we park it. And that's another demonstration of the parking garage. And now we're going to take a look at whether we can get it mapped, working with the memory map without using our car sensor at all. So it'll just be basically the software solution. Okay, this is the attempts for trying to load cars with memory maps, and it's the same process as before. We just press our button and try to load it at whatever level in an open position. Now we aren't using the car sensor at all, so we just start with all positions, all levels open, and we'll just show one going into the second story. And again, our actuator isn't working very well, but what we want to do is we want to really look at where they're loaded, and so what we're going to do is going to look at our screen and see what happens. Okay, and this is just a quick little block diagram of what happens with the software. And what we do is when we get a request, we enter one of the level empty occupied registers into our active register, and what we do is we do a bitwise AND with a mask sequencer that's based on what position the carousel's at. So what we do is bitwise AND and we compare it. If it's 0, that means that there is an empty spot. We just load in the we activate the actuator, and we also add the previous value that was in the register before to our mask value, and that's going to give us a new value, and we put that back into the empty occupied register at the end of the full sequence. Now if it's not 0, then that means we need to rotate the carousel one spot. When we rotate the carousel one spot, we also take our sequencer and move it one spot. So if we had a mask for the second spot, so it would be 0, 1, when we move it one bit, it'll be 0, 0, 1. And we go through the same process until we find an open space. Okay, now we had just loaded one into the second level, and as we can see that the second level shows a bit there. So if we put another one in there, what's going to happen is it's going to go up to the second level. It'll realize that that is full, so it'll rotate one position and load it into this position. And we rotate, and now it goes into this position. Now our counter is at this position, so we can load it into the open spots on the first level or the third level. And the third level, you go up there and it's going to load in this bit right here. And it does. And we'll just finish off. Well, what we'll do is we'll put another one in the third level. Now it'll go up, it'll see that it's occupied, it'll move one space over and put it into this spot. So we go up, we rotate one spot, and then load it in the bit. Now I'm going to turn the camera. Okay, we've readjusted things a little bit. We're going to try to put another one in level 3, so it should go into the first, second, third, fourth position, but we can see the thing rotate, and you can just verify that it does do that. So we go over here and we press our third level. We go up to the third level, stops, knows it's full, it rotates, then it proceeds back down into the home position. And over here, if we look at it, now we've got positions 1, 2, 3, and 4 full. And now we can fill up either first or second without any rotation. It'll just go immediately and fill that position. And here we'll do first floor. And that position is full. And if we do second floor, goes up, second floor, fills it. And now all 3 positions are filled. So if we go to any position right now, it'll have to rotate once again. And it doesn't matter which position we press, we'll just do the first floor. So it rotates, it fills the one next, and then that's that. And if we go over here, finally, if we look at that, we were at this position with them all filled, and then we go over to the first floor and that position is full. And that is the basic way our memory map works. And that concludes the capstone project for the parking garage.